kind of about the unit exam coming up. And so the unit exams here are always on Thursdays, right? The unit exams are in here are always on Thursdays. And we have the 4th coming up, and so we're going to do it a week from that. So actually 2/11, okay, should be probably your Unit 1 exam in here.
Can I take mine early? Like this Thursday early?
You want to take yours this Thursday? I won't have it ready for this Thursday. What's your time frame?
I leave Friday.
Leave Friday?
And come back Friday.
We'll talk about it.
Okay.
Because I might be able to knock one out by this Thursday.
Okay. If not, I mean.
Yeah, it's going to be harder for you to take it because we wouldn't have done the,
Yeah.
but
I
it's not
rather take
impossible.
it.
Okay, yeah. What we're talking about up here is like if you know that you're going to miss a test, let me know ahead of time, and like you're going to go on your trip now, right?
Yeah.
Okay. And we'll, bless you, I can set you up in the Success Center. I think that's going to work. Okay.
Or I can do it like really early Friday. Would it have to be really early?
Well, Thursday's lab isn't going to help you probably on the test. I don't know, it might, but, so we can talk.
I can look ahead. Yeah, it'll be fine.
You'll know because we have lecture today and Wednesday.
Okay.
So today, if you have your calculator handy, you might want to be kind of checking things. I have extra little calculators if anyone wants to borrow one.
You have to have one of the little ones before the test.
You have to have one that's not programmable. Like that's not programmable, and that's not programmable,
I know mine. I've got
and
the
that
Casio.
is programmable, and that is programmable. So you'll want to get something before the test. Or I always bring these, and they're not bad. I got them at the Dollar Tree. Guess how much I paid for them? So yeah, that's probably
Yeah.
programmable. Yeah.
So if we don't want to go out and spend money, if we already have a calculator, can we just use yours?
You can just use mine when you come. Yeah. Calculators are a little different though. And did you want to use one today and see what you think?
Yeah. I just don't want to go out and
Yeah.
buy a calculator when I have one, because I need
But-
one for my math class.
Yeah. A lot of times, if you're at the Dollar Tree buying stuff anyway, they have these there.
I think I have an extra one. Let me check. Pretty sure.
Did you want to try one for now, or are you guys?
I know I have one. I have one.
Okay, you're set. But I don't blame you for wanting to get another one. Not wanting to get
I
another one.
might see if I can find one at the Dollar
Yeah. Yeah. It's a game, right? We play an important game. So these are equivalency statements. Now I'm going to talk you through something called the factor label method of working problems. And I'm going to have to see you work problems this way. And I was looking at your textbook this morning, Tro. Just great. Tro talks you through this idea of basically kind of having what I call ratios and setting them up to make sure units cancel. That's what we're setting up for the factor label method. Now these are what we call equivalency statements, and we use these oftentimes to work problems using the factor label method. And I think the other day I put an arrow next to that one, and anytime you see an arrow, that means you have to memorize this. So yeah, so memorize that one. You don't have to memorize the other two. And the thing actually about the exact relationship between an inch and a centimeter is actually, it's by definition. Anytime they do something smart in science, I always say, well, that must be a woman that thought of that idea. But by definition, within the English and metric system, we have this cool thing going on with regard to length. Now notice that we have of course, gallons is English, okay, and liters is metric, okay. Pounds is English, and grams is metric. So these are equivalency statements between the two systems. And we'll be using those we'll be using those. So I had an arrow next to this one too. This is with regard to volume, and this is both metric and metric. Within the metric system, volume, we got this cool thing going on. 1 milliliter is exactly equal to 1 centimeter cubed. So you need to know that one too. That one will come in handy. Okay, so when I say on your homework and on your test, you need to work problems using the factor label method. This is kind of what I'm after. There are no naked numbers, so like that is to say that if it's 3.92 inches, don't forget the inches. It's not 3.92, it's 3.92 inches. Okay, so always use the units. Sometimes I use the word units or dimensions, it's the same thing. Okay. Now, in working a particular type of conversion problem using this factor label method of working problems, what we do is basically we start with an equivalency statement. Okay, you know it's an equivalency statement because it has the equal sign. Okay, and from an equivalency statement we make what's called a conversion factor or a unit factor. Okay, basically you have a flat equivalency statement and you make it into a ratio, and that is your conversion factor, okay, or your unit factor. And which way you could go, and I'm going to kind of show you how you can take an equivalency statement, like there's an equal sign between my two hands, and you can make, basically you can put this one in the numerator and this one in the denominator, okay, like the top and the bottom, or I can put this one on the top and this one on the bottom. So for every equivalency statement you kind of have two options. Of course, those are related to each other by what we say the inverse of each other. Okay, so, but the bottom line is you're going to choose your unit factor so that the old units cancel out. I'm going to show you what this means. Okay, basically your old units, the thing you start with, we work problems kind of from left to right. We read from left to right. So usually like your thing on your left is what your old units. Okay, those need to cancel out. Throughout the problem, sometimes you have more than one term. And clear over here on the right, you need to have the units you want to have left with. Okay, so the new units are going to be what's going to be left. All right. So here's a kind of a quick and dirty question. So you guys would tell me in 1 foot there are how many inches? 12, yep. 12 inches. 12 inches in 1 foot. So in 2 feet there would be 24 inches. And then a half a foot is 6, so we took 24 plus 6, I get 30, yep. 2.5 feet is equal to 30 inches. And this is a good example because we're going to work this using the method that you need to be using. So if you wrote down 30 inches, I'd just be like, oh, partial credit. Okay? So it's true, there are 30 inches. And can you see where actually there are 30 inches, but, and this will kind of shake out as you work the problem using this factor label method. But how many significant figures in this number? 2. Yep, there are 2 sig figs in that number. Perfect. How many sig figs in this number? Just 1. Yep, only 1. Okay. As we work this problem, I'm going to kind of show you that what we multiply through, we're allowed 2 significant figures in our answer because of the 2.5. How many sig figs in 2.5? 2, yeah. So that's kind of where we're going with that. So there's a good, right off the bat example of if you were to put 30 without the decimal point, you'd actually lose a little bit of cred. No. You'd lose a little bit of points because you didn't show 2 significant figures. So what is this with this whole factor label method? So what you do is basically you choose an equivalency statement that will kind of get you from your old to your new. And sometimes, and you're going to have some homework that's going to be due Wednesday, you can't do it in just one fell swoop. But if we were asked to get, like we were, from feet to inches, we know that there's this relationship, exact relationship between feet and inches. So that's our equivalency statement. So any equivalency statement, you actually can have 2 conversion factors, and here are your 2 conversion factors coming up. But one of the things, the reason conversion factors work is if we have an equal sign like this, we can do the same thing to both sides, and we're cool with that. So for instance, if we divide both sides by 1 foot, divide both left and right by 1 foot, we have 12 inches over 1 foot. We have 1 foot over 1 foot. What's 1 foot over 1 foot? It is 1 foot over 1 foot is just simply just 1. 1 foot divided by 1 foot is 1. So the cool thing about here is if you are multiplying, if that's what you're doing, if you go ahead and multiply by 1, you don't change your term at all, do you? Multiplying by 1 is fair. It's the identity property of 1. So that's why they call it the unit thing. So this is to say that, I could insert 12 inches over 1 foot, and because they're equal, But do you see where I got that? I basically took 12 inches and I stuck the 1 foot underneath it. Okay. We could go ahead and instead of dividing by 1 foot, we could divide by 12 inches. And now 12 inches divided by 12 inches is equal to 1. Okay. So actually here at the bottom, these two things, 12 inches over 1 foot and 1 foot over 12 inches, those are our unit factors. They are equal to 1. We can use those willy-nilly if the mathematical operation is multiplication and we're not changing anything. Okay? So those are our two unit factors, conversion factors. So let's see. Sometimes I call this one A, okay, and I call this one B. So we are now going to go ahead and use A or B to go ahead and get from 2.5 feet to inches. Now, my suggestion is usually to go ahead and start with the term you want to convert. So going back a few slides, the thing we want to get to inches is 2.5 feet. So I always on the left put 2.5 feet, and I go ahead and put it over 1. Now, a while back when we were actually going through our syllabus, do you remember where I talked about if you have a set of ratios, I'll put 3/4, I'll put 2/5, I'll put 15/7. It's kind of weird, okay? We can actually kind of think as basically a common divisor going through all of them. So can I cancel anything? I can cancel the 2 and the 4. Okay, so this is all the way going to go away, and this is going to factor out a 2, so that leaves that 2. Does that look okay? Anything else I can cancel? The 5 and the 15. The 5 entirely goes away, and 15 is 5 times 3, so that leaves me a 3. Okay, so that sort of canceling, what you guys have just done is cancel numbers. And we could kind of, let's see, is there anything else we can cancel? No. But kind of actually what we're going to do with our chemistry problems is we're going to basically pull things that didn't cancel. I've got a 3 and a 3. So 3 times 3. Anything that didn't cancel has to show up. 2 times 7. Okay, and I could go ahead and finish that up. Which I'm not Rain Man. I don't know what that is. But if you go back to your A and B, like in the previous slide, we can use one of those to make feet cancel. How many people think we're going to use the ratio A to make feet cancel? We see some possibilities, yeah. So if we go ahead and introduce 12 inches over 1 foot, okay, that's the exact same thing you guys were doing with numbers. Okay, basically this is over 1. Now my units of feet cancel. I'm left with units of inches. So when I work physical science problems, I'm all about my units. If my units come out right, in this case I'm after inches from feet, if they come out right, I'm like, cool. I can basically say I'm going to ace that problem. If my units don't come out, and you can get kind of complicated physical science problems like in physics, okay, my units don't come out, I probably set it up wrong. Okay, so it's kind of like we did before. The name of the game is to go ahead and cancel what cancels, and to go ahead and bring over here, and we're going to bring over everything that didn't cancel. So I'm going to have to go ahead and put a 2.5 up here. I'm going to put a 12 up here. I'm going to put an inch up here. And then the bottom, I don't have anything, right? Okay, so that's 2.5. So 2.5 times 12 on my calculator will display 30. And we talked about what your calculator displays before. My calculator will display 30. And of course I bring down the unit inches. Now I got to do one last look at this. This is one of the things we've already talked about in this class. How am I going to round it? Well, I'm going to round it since I'm multiplying according to significant figures. And I think we talked about this before. I have 2 significant figures here. Now, The deal, how this works, that I circled there, remember the 12 inches is exactly equal to 1 foot. So honestly, I mean, it's important to the problem, but with regard to counting significant figures, nope. Don't count significant figures there because there's no uncertainty in the 1 or the 12. So that's why we need to go ahead and show it with 2 significant figures. And that comes from the 2.5. Okay? So you're like, oh my gosh, I told you that was the answer about 10 minutes ago. Well, the problems get harder. And the other thing is, in your homework and in your tests, you have to show it working it out this way. Okay, so that's it. I think this, my slides now go ahead and say, now if we were going to go with the other ratio, which we could have, that wouldn't do so good with regard to units, okay? I'd have what, feet squared over inches, my units, and you know that's not right. So sometimes later on in chemistry, when we start to work problems like from grams to moles or moles to grams or something like that, if your units don't come out, then look at it again. All right.
Miss Myers,
Mm-hmm.
when I was in chemistry in high school, with the way, like 2.5 over 1 is what you wanted, and then we would just do 2.5 feet times 12 inches all over 1 times 1 foot, and that's always just how it was easier.
Say that
for me to-
again.
Like, if you have the division bar, you put it 2.5 feet times 12 inches over 1 times 1 foot, and you just have the division bar go all the way across.
Right.
And then you can cancel out that way.
Right.
And it's just easier for
Okay.
me to see. Is that going to be okay
Yes.
if I use it that way?
Yeah, that will be fine. Yeah, as long as, because if you do it that way, I'm gonna see both of those, right?
Yeah.
Kinda, yep, yep. Like I said, I think Tro, your author of this textbook, he might do it more like this, but I do think that would be fine, Jessica.
It's just easier to see it.
I think
And
I've seen,
for me.
and this might be what you're describing, I've seen other students come through here and they have kind of almost like a this sort of thing going on, like
Yeah.
instead of the parentheses. Yep. Yep,
I'm
yep.
just trying to make it easy to see especially with the units, it's just easier to see it when it's all over each other instead of separated.
Yeah, yeah.
I didn't know if that would be okay.
Yep, that will be fine. So let's do another problem. And this is with regard to length again, but notice we got the whole English metric thing going on. Now this is, we're going to use an obvious equivalency statement is that one you're supposed to memorize between inches and centimeters. 1 inch is exactly equal to 2.54 centimeters. So actually that's what we're going to use here. Okay. So sometimes when I kind of show how to work these, I'll show them flowing like this. So they read this from left to right. We're going from centimeters to inches. And over the arrow, I put how to accomplish that. So the equivalency statement of 1 inch is exactly equal to 2.54 centimeters is over there. So ready to knock this out. The first term is going to be the centimeters that we want to convert. Okay, we'll put it over 1. And I know my slides don't necessarily have it, but I would put 5.52 centimeters over 1. Okay, and now this is where we're going to use this equivalency statement. We know that we want centimeters to cancel, so we're going to have to put, and sometimes I do it this way, so we're going to put centimeters in the bottom, and we're going to put inches in the top. Sometimes I just focus on the units, and then I go ahead and back and fill in the numbers. So the 1 inch goes in the top, and 2.54 centimeters goes in the bottom. And then my centimeters have canceled, and I'm liking it. We can go get a cup of coffee. So how are we going to round that? What do you think? Hold up, let's hold up your fingers. How many significant figures? 3, exactly. Yep. So 2.17 inches. And it never hurts to say, does that seem reasonable? So we know that an inch is bigger than a centimeter. 1 inch is exactly equal to 2.54 centimeters. So 5.52 centimeters is fewer inches. So a lot of times that's a good thing to do, take one last look at it. All right, let's do another one. Now, you definitely don't have to memorize this relationship. I don't have it memorized. But I think those equivalencies that if you go back to the first page or one, was it there?
No, I converted the ounces to pounds.
Ah, okay, because ounces is there, but pounds isn't.
Yeah.
Yep, yep,
So I just did ounces to pounds, and then I did pounds to grams.
yep, exactly. I think that's the way I do it too. What Megan's saying is we don't have an exact link from grams to ounces, but we do from grams to pounds.
But it says that right here, like it says ounces to blank to
Oh,
grams.
thanks.
I was working ahead, but.
Thanks. So we are going to go from ounces to pounds first, and the reason is that we have this one. This is the one we have earlier. And I'm counting on you knowing this one. Now, maybe. How many ounces are in a pound?
16.
16. When it gets, I know, sometimes I have to concentrate. There are 16 pounds and 16 ounces in a pound. So to work this, there you go. That one that I just showed you, I would give it to you on a test, okay? This whole, English to metric weight thing, okay? But this one, I'm counting on you knowing.
So which ones do you want us to know?
Well, now that's English, so that's within the English system. I don't have any arrow to show you, like I didn't put an arrow next to know that 1 foot is exactly equal to 12 inches. And so I'm not putting an arrow here. I'm kind of laughing because I know it can be an issue.
I know the metric system more than I know the English.
I would say that if you're taking a test and you're like, it looks like Mrs. Snipes expects you to know this, and you're like, what the heck? Feel free to come up and say, is that right? Because it's within the English system, I'm expecting you to know it. So.
Okay. So the ones that are in the metric system that you want us to necessarily memorize are the inches to centimeters, inches to foot, like those kind of things?
Yes, the inches, 1 inch is exactly equal to 2.54 centimeters, and then 1 milliliter is exactly equal to 1 cubic centimeter. And actually, we're going to come back and look at the metric prefixes here in a minute too.
Okay.
So.
I just want to make sure those are the ones we need to know for the test.
Yeah, she said, are there 16 cups in a gallon? I don't know.
Well,
That's
I'm pretty
probably
sure
one I
it's-
wouldn't put on a test.
Well, because there's one right here, but.
There's 60, isn't it
there's
64?
There's 4 cups in a quart, right?
4 cups in a quart.
I'm drawing my gallon picture. Yeah, so there would be 60. Can I Google that?
You can, but we're going to go on. Okay, so we always start with the term we want to convert, which is 2.57 ounces. We're on our way to grams. And this was where now we're going to go ahead, and we said we're going to go through pounds. So we're going to use this equivalency statement as a ratio down here. We want ounces to cancel, and we want to be left with pounds. And so that's why I kind of do it that way. And then I'll put 1 pound and 16 ounces, just like that. This is over 1. So you can cancel as you go, like our ounces will cancel. And we have units of pounds, and now we're ready to execute this second part right here, okay, where we're ready to get away from pounds, and we're going to get to grams. And this is where then I go ahead and stick in those numbers. I have 1 pound is approximately equal to 453.6 grams. And then the beauty of that is our pounds have canceled. We're left with units of grams, which is exactly what we were after. So number-wise, it looks like on the top I have so I collect my numbers and I collect my units. So on the top I have 2.75 times 453.6 times grams. And on the bottom, looks like I just have ones other than 16. Okay, so All right, now, your calculator's gonna display an answer, but let's take one last look at it. How are we going to round? All right, get your fingers ready. How many sig figs are we gonna give our answer? 3, it's right. That's right. So why don't we limit it because of the 16? You're right. Because it's by definition. It's equal to, because 16 ounces is exactly equal to 1 pound. All right, very good. So rounded to 3 sig figs, I get 78.0. This is a good example where, I can't remember what your calculator displays, but where you might blow off that trailing 0 after the decimal, but you need it to give yourself 3 sig figs. All right. Next problem. Word problem is just an issue, isn't it? Okay, kilometers and millimeters. Arr. And a number packed up in scientific notation. But I've seen you guys do scientific notation just fine. Now, notice that kilometers is big. Kilo actually is 1,000 times. And milli is small, 1/1000th of. So actually what I usually do is go through the meters. So to work this, I probably would go from millimeters to meters, and then meters, scale it up to kilometers. I just would. Okay. And so in blue, above kind of how do you get from millimeters to meters? Well, milli means 1/1000th of. So in 1 meter, there are 1,000 millimeters. And how do you get from meters to kilometers? Well, kilo means 1,000 times, so 1 kilometer is equal to 1,000 meters. So those are my 2 equivalency statements to get from millimeters to kilometers. Now, I do understand the concept of just using the powers of 10 to go straight from millimeters to kilometers, but it's dangerous. Okay, this is how I would do it so I don't make a mistake. So the first term is going to be that 1.2 times 10 to the 9th millimeters over 1. That's the thing we want to convert. So what's our second term there? We want millimeters to cancel. What's the next term? Yep, 1 meter over 1,000 millimeters, exactly. So millimeters cancel. Perfect. And then what's the last term? We want meters to cancel now.
1 kilometer over 1,000
Yep. 1 kilometer over 1,000 meters. Perfect. And then our millimeters cancel. So now it looks like we have 2 terms of 1,000 in the bottom. Of course, we have 1.2 times 10 to the 9th in top. And I have to successfully put that in our calculator. Okay, and our calculator is going to display a number. Now, how many significant figures do we give our answer? Fingers, please. Significant figures for our answer. 2. I'm liking it. So you should get this. 1.2 times 10 to the 3rd kilometers.
You have to set it up like that. 'Cause I literally wrote.
No. You can show your answer as 1,200 kilometers because it's the same diff. That gives you
Okay.
2 sig figs. Yep.
Okay.
Yep. But if you were after 3 sig figs, you'd have to go to scientific notation.
Yeah.
Yep. Very good. All right. That was within the metric system. Okay. So is this the next slide you guys have? Or is this a repeat slide?
That's a repeat.
Okay. Is this the next slide you have? Okay, good. Okay, on to volume, specifically kind of fluid volume. Well, it's fluid volume, but, okay, cups is English and milliliters is metric. Trying to think. Oh my gosh, yeah, this is one, like we were just talking about.
Yeah, I just finished.
If you go back a few slides on that one that said you have to memorize the inches to centimeters, and then there were like one with mass and one with volume, The one with volume between English and metric is like gallons to liters. It's like, oh my gosh, are you serious? So basically we can take cups to gallons, we can cross then to liters, and then we'll have to take liters to milliliters. Okay? We can do it.
I did it and it took a long, like an extra step that was kind of silly. So I did the, like the milliliters to liters and then the gallons to cups.
Okay. So I'm going to show you, this actually brings up a good point that a lot of times there's more than one way to set this up, to work this, okay? So I'm going to show you one way to work it, probably the longer of the ways. So we know the liters to gallons thing. We got that. We got that from the table. We got that. That's actually crossing the empirical bridge. So like I said, we kind of have to, and I said it backwards a minute ago, didn't I? We kind of have to get from milliliters to liters. We can do that by the factor of 1,000. Now, if you're like me, the factor of 1,000 between milliliters and liters, you have to concentrate. Which way is it? Okay, liter is big, milliliter is little. So you have 1,000 little milliliters in 1 liter. Okay, that's a very common mistake. So once we get to liters, we can go ahead and use that equivalency statement. Now, once we get to gallons, and did I just have one? I guess I did. Yeah, it was what you said, Megan, right? You said 16 cups in 1 gallon?
Yeah.
Okay. Now this, honestly, I'll go back. I would never put this on a test. I would never ask you. I just cannot.
Well, the next one was crap. Like, how many yards are in a mile? I don't know. I gotta Google it.
Yeah, yeah. So I probably would not make you, the thing I would not do on a test is make you know the 16 cups is equal to 1 gallon. Now, we're going to work the next one coming up. So what's our first term is going to be the thing we want to convert, which is 275 milliliters over 1. Then we're going to go to liters. What's our next term look like if we want milliliters to cancel?
1 liter over 1,000 milliliters.
1 liter over 1,000 milliliters. Very good. Milliliters will cancel. And then we're going to go ahead and go from liters to gallons. What does the next term look like?
1 gallon over, or no.
Yep.
1 gallon over 3.7.
Yep. 1 gallon over 3.785 liters. Perfect. Liters cancel. Now we're ready to knock it out to cups. What does that last term look like?
16 cups over 1 gallon.
Yep. 16 cups over 1 gallon. Very good. So let's go ahead and how many sig figs do we need to round this to? Fingers? 3. Do you buy that, Caitlin? Does it look like 3 sig figs to you too? Does it? Okay. Because like the way it works is you can just go back and you can count sig figs. 1, 2, 3. Now there's no uncertainty brought within the metric system. There is uncertainty here, but there's 4. And then here, there is no uncertainty brought because that's exact. Okay, so 3 sig figs, this is what I got. 1.16 cups. But Megan's right, Google is really cool. Have you ever, if you use the word convert, and if you look convert 275 milliliters, and if you say 2 cups, it'll spit back this number. Go to Google. Yeah. All right. Another one. Now this sort of problem could be on your test because it introduces a new length, a rod. You're like, rod, I thought that was a person's name. Well, it's actually also a unit of length. Now, be careful when you read a problem like this for homework or for a test. It gives you an equivalency statement. Do you see this where you're like, Rod, what the heck? Where's my coffee? Where's my chocolate? Okay, but then it says 11 yards is exactly equal to 2 rods. That's an equivalency statement. So actually here when we work this problem, we're going to pick out 11 yards is exactly equal to 2 rods, R-O-D. Okay, they're telling you that. So how many rods are in 2.5 miles? So we're going to start with 2.50 miles, and we're going to maybe do a few things, and we're trying to get 2 rods. Okay, that's just kind of, and sometimes if you don't know how to work a problem, feel free to kind of just diagram it. Well, right here from this equivalency statement from the problem, we know if we can get to yards, then we can go ahead and get to rods. So how are we going to get from miles to yards? Well, if you remember, is it 5,280 feet? No, I'm just saying.
Yeah.
By definition, the way a mile was set up is it's so many feet.
It's ridiculous.
Yeah. And actually, that's how we're going to do it. Some of you may have memorized it. I probably would not put that on a test, but that is a common thing to memorize. Okay, so again, we can go ahead and finish up the problem from yards to rods using the equivalency statement that was given in the problem. It was no small thing that the story problem actually said that's an exact relationship. That's on purpose. Okay, so we can get from, if we can get to feet, we can get to yards by the whole 1 yard is equal to 3 feet. 5,280. Yeah. A lot of times people come into this class and they have committed that first equality to memory. I would probably have to look it up just to make sure. And that is an exact relationship. This is by definition. So if we can go ahead and get from miles to feet that way, by that exact relationship, we can get from feet to yards, of course, there are 3 feet in 1 yard, and that's also exact. So now this strategy is how we're going to go ahead and knock this problem out. So the thing that we need to convert is 2.50 miles. Put that over 1. And according to this strategy, we're going to go to feet next. So can you use this first blue equality up here to get miles to cancel and be left with feet? What does that look like? Yes, 5,280 feet over 1 mile. Perfect. And we did that so our miles will cancel. So our miles have canceled, we're left with feet. Now how do we use that second equivalency statement to get feet to cancel?
1 yard over 3 feet.
Yep, 1 yard over 3 feet. Our feet have canceled, now we're left with yards, and then how do we use that last equivalency statement?
2 rods over 11.
Yep.
Or, yeah, 11
Yep, you're right.
yards.
2 rods over 11 yards. And that's it. So get your fingers ready. How many sig figs? 3 sig figs. Very good. Okay. So hopefully you would get a number like this. And this is another good example. To show 3 significant figures, I don't know what your calculator displays, but you have to put a decimal after that last 0. Or pack it up in scientific
It does
notation.
show it.
What's that?
It does show it.
It does show it? Okay.
Why would it be 3 or 4 if like 5,280?
So you're on the right track there. You always go low. I use the word conservative. Conservative means like skimpy. So you're always skimpy. So, yep. And the other thing, actually, this, as it turns out, is exact. There are not very many exact things, but since that's exact, actually, we don't even count those. But yep, we're always skimpy. Okay, so what I'd like to do is actually go ahead, we'll work this problem Wednesday, but I would like to, I'm trying to go up to the, that's funny, okay. You have an assignment slide, it looks like this, right? Okay, good. So let me pull up some hints about this assignment. This will be due Wednesday. We're back to chapter 2 from 13. Let's see. Uh-oh. I mean, it's nothing too bad, but, oh, there it is. It's weird. Okay. So here's 69, and you guys know that, like, you can get the answers for all 4 of these in the back of your textbook, okay? So don't forget about that. But here's the trick, and here's why I don't feel so bad. you have to use, and I think the slide says, you have to use the factor label method, okay? So here's what 69 looks like. Now, I'm showing you kind of the wrong way at first. For A, you might be like, okay, 3.55 kilograms to grams. I know there's a factor of 1,000. There's more grams. There'll be more grams, so I'm going to move it over this way. So I get an answer of 3,550, and you're right. But that won't wash, okay? So what I went ahead and showed you is what you need to do, okay? You need to, I would, and especially these easy ones, or the early ones, write down the equivalency statement. So what numbers do I put in the first and the second blank? If I put a 1 in, yep, if I put a 1 in 1,000, exactly, yep. And so just like we've been working problems, that's actually, we're going to take that equivalency statement and turn it into a conversion factor. The first term is going to be your 3.55 kilograms over 1. And the second term is actually going to be a ratio that you get from that equivalency statement, okay? All right. Yeah, I think you're fine with that. Now, here in this chart, we were talking about what you need to memorize. Here in this chart from your textbook, actually, I told you the 4 prefixes are kilo, centi, milli, and micro. So you need to memorize those. And then kind of over here is... let's see, kilo is 1,000 times, and then here we have 100 times, 1 1,000th, and 1 1,000,000. Okay? Cool. Now, the second one, oh yeah. So for C, I went ahead and gave you a hint. For C, notice it's kind of like one of the problems we did, where we're starting out with something small, milli, and going to something large, kilo. Okay, I would actually do it with 2 equivalency statements. Now, down here, 71, I went ahead and I gave some hints that you may or may not need. Now, the way my hints work is you may or may not need them, okay? So these will be pushed out on the Twitter feed. I'll just wrap this up as a PDF. What I have some of my chemistry students do is sometimes they'll print it off and they won't use it. PDF you can print off. Remember, you guys got free printing here at the lab. Or sometimes, you know, they'll have it handy if they need to. So those are just some hints about that one. Notice that you're using, for instance, nano and pico. I mean, those are not prefixes I'm going to hold you accountable for, but you do have the table there to show you how they work. Okay, so that was the first 2 problems. The third problem, I've gone ahead and given you some hints. Now, again, do you need these? I don't know. Okay, but one of the things you can't do is just Google it and write down the number. That would be so silly. Okay, but I've gone ahead and kind of given you some hints. If I were working them just this morning at my desk, this is probably how I would work them. So there are hints there if you want them. And then the last one, kind of similarly, I just kind of gave some hints. Some of them take longer than others. I think it looks like 73 went from English to metric, and it looks like 75 is going from metric to English. So, okay, it's all good. Awesome. So that's all I have, and we'll hit it again on Wednesday.